All right, good morning, guys. Today we are going to be covering 10.1 surface area of prisms, specifically of prisms today. Now, Unit 10 will be covering three-dimensional figures in space, so you're going to be seeing a lot of surface area problems, lateral area problems, and then when we get a little bit deeper into the chapter, we're going to see some volume problems as well. Those are the three main things that you're going to be seeing throughout this chapter. So make sure that you're comfortable with not only surface area, but lateral area and volume as well. Today, again, we are focusing on prisms, and our learning target is I can calculate the surface area of prisms. So let's go ahead and get started. Again, just to recap the 3D shapes that we're going to be exploring, because that's what this chapter is all about. The first one that we're going to be exploring is prisms. Now you're going to see this in multiple shapes. You're going to see rectangular prisms. And again, it's rectangular because the only shapes that are there are rectangles. And you're also going to see triangular prisms. Now triangular prisms get their name because there's two triangles on either side, and then they're connected by a bunch of rectangles as well. But again, when you're determining what type of prism that you're dealing with, you're always looking for shapes that aren't rectangles. And if there's only rectangles in the prism, then it's a rectangular prism. But if you see one other shape, then it changes to whatever that shape is, but it's still a prism. After that, we're going to go ahead and study pyramids. Pyramids are very similar to triangular prisms, except pyramids all meet at one single point at the very top. Now you guys have seen prisms in the past. Hopefully you've seen them in history books in Egypt and whatnot. So keep in mind that pyramids will always meet at a point. Triangular prisms will not meet at a single point because they're all connected by segments here. After we finish up pyramids, we're going to see what cylinders are looking like. Again, we're going to be exploring cans of soup and things like that. So that'll be a pretty fun one to explore. And then afterwards, we have cones. Cones are extremely important for everyone in this class because once you get into pre-calc, you're going to be dealing with conic sections. So you're going to be cutting this cone in different shapes and seeing what occurs when that happens. So cones will be a very big topic for you guys down the road. From there, we'll cover spheres at the very end. Spheres are just circles, but they're like balls. So it's a three-dimensional circle. And again, today, our main focus is on prisms. So that's what we're going to go ahead and focus in on now. So to get started, we have a little bit of a warm-up problem, and this warm-up problem is fairly difficult. It is very similar to questions that you'll see down the road, and you'll even see questions like this, even as far as calculus. It asks, what figure out of the previous figures that we just saw in the last slide is generated by rotating the region enclosed in the first quadrant by the function of y equals negative x plus 3 around the y-axis? So the first thing that we need to do is we need to label our quadrants. And we know that we have 4 quadrants. Quadrant 1 is in the top right. Then it goes 2, 3, and 4. So we want to label up all these quadrants so that we know that we're only working in the first quadrant here. So when I graph this line, y equals negative x plus 3, it needs to stay in the first quadrant. So the next thing that I do is graph this line. Starting up, I see that my y-intercept is positive 3, so I can go up 3 and graph a point. And then I can follow my slope, which says to go down 1 and to the right 1. And if I continue doing that, I'll eventually intersect the x-axis at positive 3 as well. Again, we want to stay in this axis here. Now from here, what would happen if we rotated around the y-axis? Well, a good way to think about this is to think about tetherball. So we have Napoleon Dynamite down here playing tetherball by himself. And when you're playing tetherball, this ball is going around the pole. So we can think of our y-axis as the pole here. And when it goes around this pole, what type of shape does it create? Well, the rope doesn't get any shorter, so it's very taut the entire time, and it would have to go around in a circular pattern. And since it's going around in a circular pattern, it would create a cone. So the three-dimensional shape that it would create, assuming that it is a solid as it goes around, is it would create a three-dimensional cone. Now, of course, the bottom would be open, but we still have a cone nonetheless. Now, if I had a triangle instead, then it would create a cone with a bottom on it as well. So let's go ahead and jump into the topic of lateral area. Now, in order for us to find surface area is the total outside area of the shape, we first need to learn about lateral area. So first off, we have these prisms up here. And one is in 2 dimensions, one's in 3 dimensions, as we can see. Now, first off, what type of prism is this? Well, this prism is a triangular prism because we have triangles within it. And as we can see, these 2 sides are both triangles. So these are triangular prisms. Now, on the left side here is the 3-dimensional prism itself. So this is typically how you guys would be looking at prisms. And a good way to think about this in comparing the 3-dimensional to the 2-dimensional is to think about boxes. So when you have a box, typically it's in 3 dimensions. But when your parents ask you to throw away the box, you need to break it down into a 2-dimensional shape so that it fits better in the trash can. So that's what this net is. And this is what we call it. This 2-dimensional figure is called a net, like what you go fishing with or catching butterflies with. And in this net, it's just flattened out this 3D shape. And as we can see, the height can be found right here. And A, B, and C, that's the distance around the triangle. But if I were to lay this out, well, A is the length of one rectangle, B is the length of another rectangle, and C is the length of our third rectangle. So therefore, A plus B plus C equals the whole distance of this rectangle. Meanwhile, the height of the rectangle is, of course, the height of our prism. Along with that, this blue section, the section without the 2 bases, without the 2 shapes that are different, that is called our lateral area. So our lateral area is the area of this blue section. We want to write a formula for L, the lateral area, in terms of H, A, B, and C. Well, looking at this is just a big rectangle. And we know that the area of a rectangle is just base times height. So therefore, lateral area is equal to height times our base. Well, our base is A plus B plus C. And along with that, this is how we can find the lateral area anytime. Now, you may be able to also figure out the longer way of just figuring out the area of each of these rectangles and then adding them together. That'll take you much longer than using this formula. Next, we want to write the formula for L in terms of P, where P is the perimeter of the base of the prism. Well, the base of our prism is these triangles. And the perimeter of our triangle, the base, is A plus B plus C. Well, we see that in our previous equation. A plus B plus C is right here in red. So that must mean that this is the perimeter of the triangle. So therefore, lateral area is equal to the perimeter of our base, whatever the base of our prism is, in this case it's a triangle, multiplied by the height of the prism. So this is our equation for lateral area. And again, P is the perimeter around the base. So, just to recap, we just saw it as a triangular prism. Just to recap, a lateral area is the area of the figure without the bases. Here's what it would look like in a rectangular prism. And as you can see, I just chose 2 rectangles and said that those 2 are my bases. And as such, they were not colored in. So my lateral area would just be the area of this big rectangle here. Now, of course, if I chose 2 different sections of the prism as my base, I could have chosen these 2 as my base. Then I would have had to find the area of all these blue pieces. So again, it changes based upon what you're looking for and based upon which sides you're choosing are the bases and the heights. Now, just as a general rule, you're always going to see me choosing the top and the bottom of our figure as the bases. It makes the most sense and it's the easiest to deal with. And plus, it makes it so that we're consistent each and every time. Now, the surface area is also known as the total area. It's the area of the outside of the whole figure. So if I have the same exact figure as above, the surface area is just all of them. Instead of all of them but the 2 bases, surface area is all of them. So therefore, we can think of surface area as the lateral area plus the 2 base areas that we have. All right, let's go ahead and figure out some equations for these. So the lateral area of a right prism with height h and perimeter p is blank. Now, first off, let's focus in on the word right here. Right is talking about the height and the base. So that means that the height and the base meet at 90 degrees. Now, that's very important for us because if it's at an angle, it changes very slightly on how we solve for this. But again, it's just saying that the height and the base intersect at 90 degrees. Again, lateral area, we found out was just perimeter times h. That is going to be our formula. Make sure that you have this down. Where p is the length of the base. I like to think of it as the perimeter of the base. That way I'm not thinking about stretching out that net. Meanwhile, surface area is a little bit different. But before we talk about surface area, what type of prism is this? And the reason I keep asking this is every year someone makes this mistake, and it happens more often than I would like. So I'm going to keep asking. This is a triangular prism. And again, I know that because I see rectangles all around, but as long as I see a triangle in here, I know that it's a triangular prism. All right, now let's go ahead and talk about surface area. The surface area of a right prism with lateral area L and base area B is blank. Now, first off, we already know that this is a triangular prism. It's the same exact figure as the previous prism that we just had. And with this, we know that the triangles are our bases. So we have our lateral area in the center here, and it's sandwiched in between the two bases. Now, what I'm drawing here is the net so that we can really make sense of the lateral area L, which is in blue, and the bases, which are in red, the two triangles. Now, surface area is equal to the lateral area plus the area of two bases, whatever those areas may be of the bases. If they're triangles, I'd use the area of a triangle. If it's a rectangle, I'd use the area of a rectangle. Pentagon, I'd use the area of a pentagon. So it just depends on what type of shape we're given. Now, again, if I want to break this down a little bit further, I can break down L, our lateral area, because surface area is equal to P, the perimeter of our base, times the height of our prism, plus 2 times the area of our base. So again, you can break it down for each of these. Now, I can tell you right now in your homework and on your tests, you're going to be asked to find not only the lateral area, but also the surface area. So if you break it down, you'll be able to find both without having to do the problem twice. So just make sure that you're keeping in mind that pH is still the lateral area here. Again, for our variables, P is the length of the base, H is the height of the prism, B is the area of the base shapes, and L is the lateral area. In this case, since the base shapes are both triangles, the area of the triangle, big B, is equal to 1/2 base times height. So keep in mind, it changes based upon whatever shape we're dealing with. Next up, let's try out some sample problems. Each gift box is a right prism. Find the total amount of paper needed to wrap each box, not counting overlap. So we just need to find the surface area of these boxes. Now I'm going to do this one slightly different than the previous ones because I want you guys to see what it looks like with the net. So what type of prism is this? Well, all we see is rectangles, so therefore this must be a rectangular prism. So therefore we're going to use the area of a rectangle for the area of our bases, big B. So here's my net, and again, you don't need to draw the net in, I just want you guys to be able to see it. And it is just this shape. I just tipped it over and then rolled it out so that you can see that it is the same exact thing. Now, again, I can find the area of each of these rectangles and add them all together, or I can use our formulas. So we know surface area is equal to big P, the perimeter, times the height of our prism, H, plus 2 times the base, the area of our base, big B. Now, I also labeled it here for us. So the perimeter is at the bottom. I can find it at the bottom very easily because we already have these numbers, and since it's a rectangle, I know that opposite sides are congruent. So I have 6 plus 8 plus 6 plus 8 for the perimeter. Meanwhile, our height is 12, H is 12, and big B, the area of our base, is the area of a rectangle, base times height, or 6 times 8. From here, 6 plus 8 is 14, plus 6 plus 8 is 28. So we have 28 times 12 plus 2 times 48. That will give us, and again, I'm just drawing it on here as well, the area of our bases, the height, and the perimeter. This will give us 28 times 12 plus 96. If you enter this into your calculator, you're left with your final answer as 432 units squared. Now, we're dealing with three-dimensional shapes, so you may be wondering why it's squared and not cubed. Sorry, someone came and knocked at my door, but so just to continue where we left off, we are dealing with square units because right now we're finding the area. And since it's an area, it's still a two-dimensional thing that we're finding. So we may be dealing with a three-dimensional shape, but we are still working in 2 dimensions to find area. So just think, area is always in 2 dimensions. When we get to volume, a little bit further in this chapter, that's when we're going to switch to cubic. So units cubed instead once we get to volume. And the reason for that is because volume is inherently 3-dimensional, so therefore it's going to be units cubed. The last thing I really want to mention is, again, just to make sure that we're understanding what surface area is. Surface area is the outside area of the shape. And that's so important for us because when we're looking for that surface area, we're eventually going to be dealing with composite figures. And composite figures are just multiple shapes put together. So I could put like a hemisphere on top of our prism here, and I'd have to have you find the area of that. And that can make it much more difficult when you're thinking of the outside area of the shape. Because then all of a sudden I need to cover up the circle on the bottom, but I need to include the hemisphere. So it'd make it a little bit more complicated down the road. Next up, we have the same type of problem, but this time we have a triangular box. And with this triangular box, we notice that we have right angles, which is very useful for us. So to get started, again, this is a triangular prism because, again, we have triangles in our shape. And since it's a triangular prism, I know that we're going to have triangles as our bases. So therefore, we're going to use the area of a triangle. Now we know that area of a triangle is equal to 1/2 base times height. And further, base and height always need to intersect at 90 degrees. So therefore, big B is equal to 1/2 24 times 10. That give us 240 divided by 2. 240 divided by 2 will leave us with 120 units squared. So big B is equal to 120 units squared. Next, we need to find the perimeter. And actually, before I find the perimeter, we can find the height very easily. The height is the segment that connects the 2 bases. So the segment that connects the 2 red bases here is this segment right here, 20 inches in length. So height is equal to 20. The last thing that we need is P, the perimeter of our base. Well, looking at my base, I only have 2 sides. I have 10 and 24. So to find our third missing side, we need to use Pythagorean's theorem. Now this is a Pythagorean triple. This is a 10, 24, 26 triangle. But just to show you guys Pythagorean's theorem, let's go ahead and go through it. 10 squared plus 24 squared equals c squared. That'll give me 100 plus 576 equals c squared. Combining 576 and 100 will give me 676. If I were to take the square root of both sides, I'd be left with c is equal to 26. So again, this is a 10, 24, 26 triangle. Now, from here, we just need to add up all the sides. I'm plugging 26 in for c. And if I add up all those sides, I'll have the perimeter of our base. Well, 24 plus 26 is 50. 50 plus 10 is 60. So therefore, surface area is equal to P, 60, times H, 20, plus 2 times big B, which is 120 units squared. 60 times 20, well, that's 1,200. 2 times 120 is 240. 1,200 plus 240 will give us 1,440 units squared. All right, next up. Calculate the amount of cardboard needed for a food bank organization in a city for a day. The food banks will see, on average, 8,471 people on a normal day. Each box will be 12 inches by 24 inches, with a height of 6 inches. Each box will have both a top and bottom to keep items secure. We want to find out exactly how much cardboard we need. So to get started, let's go ahead and draw out our box. Again, it's 12 by 24 for our base, and it has a height of 6. And if you have trouble drawing out boxes, a nice little hint is to draw out 2 rectangles that overlap each other. And then you just connect each corresponding part of the rectangles. And as you can see, it creates a nice little box for us. Now, from here, with our box listed, we know that surface area is going to be equal to P times H plus 2 times our base, the area of our base. Well, perimeter would just be 12 plus 24 plus 12 plus 24. Height we can see is 6, and the area of our base would be 24 times 12. So, plugging in, we have 12 plus 12, which is 24. 24 times 3 is equal to 72. So we have 72 times 6. Then 2 times 12 is 24. 24 times itself is 576. Plugging that into your calculator will give you 1,008 inches squared. That's per one box. So we have 1,008 inches of cardboard per box. Now from here I'm going to use dimensional analysis. You guys have seen this in your science courses before, and the reason I'm doing it is because it allows us to see units cancel out. And that's very important for us down the road. So as I can see, I have 1,008 inches squared per box. One box is distributed to one person, and there are 8,471 people that would like a box. So we can see that boxes are on top and on bottom, they'll cancel. We have people on top and a person on bottom, they will cancel. And we're left with 1,008 times 8,471. That will give us 8,538,768 inches squared of cardboard that the organization will need in order to serve that many people. Next up, we want to find the area of the equilateral triangular prism. Now, as we can see here, we have our prism with a side length of 10 and a height of 30. So we know that h is equal to 30, and since this is equilateral, we can find the perimeter by doing 10 plus 10 plus 10. So perimeter is equal to 30, and height is equal to 30. The last thing that we need is the area of our base. And since this is an equilateral triangle, I can use the area of an equilateral triangle. That formula is area is equal to s squared, our side squared, times radical 3 divided by 4. Meaning that we have 10 squared times rad 3 over 4. Well, 10 squared is 100. 100 divided by 4 is 25. So the area of our base is 25 radical 3 units. Units squared, I should say. Now we have P, H, and B. Let's go ahead and plug it into our formula. Surface area is equal to P times H plus 2 times B. Or in other words, 30 times 30 plus 2 times 25 radical 3. 30 times 30 is 900. 2 times 25 rad 3 is 50 rad 3. 900 plus 50 rad 3 is about 986.6 units squared. All right, getting close to being done, we have a couple challenge problems to finish this off. Our first challenge problem is to find the area of the regular pentagonal prism. So as I can see, my two bases are pentagons, which changes this very slightly because the B value changes. Everything else, everything that we've been doing stays the same. So to get started, let's go ahead and find the perimeter. The perimeter of a regular pentagon should be all the sides added together. And since all the sides are congruent, and they're all 6, and we have 5 congruent sides, we can do 6 times 5, which is 30 units. So that's our perimeter. Meanwhile, the height, the segment that connects the two bases, is equal to 13. Now we just need to find the area of our base, the area of our pentagons. So, to find the area of our pentagon, I'm going to go ahead and draw one. With this pentagon, I'm also going to go ahead and create a triangle in the center that will allow me to draw my apophthegms in. From there, I want to find out the amount of degrees in each angle. Now, I know that there's 540 degrees inside of a pentagon, and I can do that because there's 3 triangles I can create in here, 1, 2, and 3, and each of them have 180 degrees. Well, 180 times 3 will give me 540 degrees. That 540 degrees is split between 5 congruent angles, giving me 108 degrees for each of these angles. Now, when I created this triangle, I had to create it by drawing in these radii. And we have to remember that radii bisect angles. So therefore, this 108 degrees split into 54 and 54. Because if I add these together, I get back to 108. From there, we don't have special right triangles for a 54-degree triangle. It just doesn't exist. I mean, we could probably create one, but it just doesn't exist currently. So, what we would need to do here is we need to use SOHCAHTOA. Starting from that 54 degrees, the side opposite is A, the apothem. The side that is the hypotenuse is opposite 90 degrees, that is blank. And my adjacent side is 3. Now, if you're wondering where 3 came from, well, it came from the 6. The entire side is 6, and the apothem intersects at the midpoint. That would split it equally into 3 and 3. Now that we know that we're trying to find the opposite side, and we have the adjacent side, we can use tangent. Tangent is equal to opposite A over adjacent 3. So therefore, tangent of 54 degrees is equal to A over 3. If I want to solve for A, I multiply both sides by 3, giving me A is equal to 3 tangent of 54, which is about 4.1. Now we have A, and we already have P, so we can solve for the area of our base. The area of a regular polygon is area is equal to 1/2, and in this case it's big B is equal to 1/2 A, the apothem, times P, the perimeter. That'll give me 1/2 times 4.1 times 30. If you enter this into your calculator, you'll get big B is equal to 61.9 units squared. Now we have everything that we need for surface area. Plugging it in for our surface area formula, surface area is equal to P times H plus 2 times B. So surface area is equal to 30 times 13 plus 2 times 61.9. If you enter this into your calculator, you get about 513.9 units squared. That is the surface area, the outside portion of this pentagonal prism. Our last problem of the day is a challenge problem, and we want to find the area of the right triangular prism. Now, again, right just means that the height and the base intersect at 90 degrees. As I can tell, this is not a right triangle, because we have an obtuse angle, meaning it's an obtuse triangle. So, to get started on this, I first want to find the height, and I can solve for that by using Pythagorean's theorem, because this 10 is the diagonal of this rectangle here. And since I know it's a right triangular prism, I know that this would be 90 degrees, so I can go ahead and use Pythagorean's theorem. Now, this is a Pythagorean triple. This is a 6, 8, 10 triangle, and if I use Pythagorean's theorem, we'll be able to prove that h is equal to 6. 8 squared is 64, 10 squared is 100. If I subtract 64 from both sides, we get h squared is equal to 36. Taking the square root of both sides brings us to h equals 6. So we now know our height. The next thing that we want to solve for is the base. And we know that we have a triangular prism, so we're going to use the area of a triangle. Now, the problem with that is that this triangle is not a right triangle. So I don't have base and height. So we're going to have to think back to Unit 7 and recall the area of any triangle. If you recall that formula, it's going to be big B, the area of our base, is equal to 1/2 A times B sine of C. Again, this equation can only be used when you have side, angle, side. So 1/2 A, which is 8, times B, which is 15, times sine of angle C, which is 104. If you enter this into your calculator, you'll get B is equal to 58.2 units squared. So we now have big B. The last thing that we need is the perimeter. But for a perimeter, we're missing a side. I'm going to go ahead and call this side length D. And to solve for D, well, I have side angle side, so I can use law of cosines. And the reason that I can't use Pythagorean's theorem is, again, this is not a right triangle. So law of cosines is going to be D squared is equal to A squared plus B squared minus AB cosine of angle C. Plugging in our values, that give us D squared is equal to 8 squared plus 15 squared minus 8 times 15 cosine of 104 degrees. If you enter all of this into your calculator, you get D squared is about 318. From here, I can solve for D by taking the square root of both sides, giving us D is about 17.8 units squared. That means I can now solve for my perimeter by plugging in for D. So we have perimeter is equal to 8 plus 15, which is 23. 23 plus 17.8 will give us 40.8 units. Lastly, we can go ahead and plug into our surface area formula. Surface area is equal to P times H plus 2 times B. P is 40.8, H is 6, and big B is 58.2. If you enter this into your calculator, you get your final answer of about 361.4 units squared. All right, guys, thank you so much for watching today. If you have any questions, please let me know.